right, let's talk through inflation and the consumer price index. So inflation is the relative change in the consumer price index for 1 year. Now, the consumer price index is a table that we use just to kind of really to track inflation, to track the change in the prices of goods and services over years. So to find the inflation rate for a particular year, we're going to calculate the relative change using the previous year's consumer price index as the reference value. So remember, relative change is found by taking the new value minus the old value and divide by the old, where old is also known as the reference. All right, let's calculate. Let's calculate the inflation rates for the values in the table. So to find the inflation rate for 2019, we are going to use 2018 as the reference. So we would take 255.657 minus 251.107 and divide by 251.107. If you are using a calculator, you want to make sure to put the numerator there in parentheses in order to do this. Now, I'm actually going to show you two different ways that you can do this. So one is this way. So when we do it, we end up with the numerator of 4.55. And then when we divide by 251.107, we end up with 0.018. Now, this is all fine and dandy, but that tells us, right, the relative change or the growth. If we want to find an easy way to calculate the inflation rate, we can also, so this is our rate, but we can also say, well, if we take 255.657 and divide by 251.107, this will give us a reference value here of 1.018. Now notice the difference between. The only difference is that on the right side, we have a 1 in the front. And the reason that is, we're saying for any value in 2018, if you multiply by 1.018, you would get the value for 2019. So it really depends on what you're talking about. This references just the increase, right? So the left side here is just the increase, and this gives us, the right side gives us our new value. So there's the difference between just the 0.018 versus the 1.018. Okay, now use your math skills, hit pause, and do the other ones, and then come back and look at your answers. All right, so we find the growth or the increase as 0.012 and 0.047 for 2020 and 2021 respectively, which gives us the new values of 1.012 and 1.047. So that means from the previous year. So again, if we would take a value in 2020, like 258.811, and multiply by 1.012, that would give us the 270.970. That's the idea of this. Now let's use that table. Which year from this list had the largest increase in prices from the previous year? Well, look at what we have. Which one of these numbers is the largest? The 1.047. So that means 2021 had the largest increase in prices from the previous year. So interpret the inflation rate for 2021 in a meaningful sentence. So if we think about this, the increase is 0.047, as we talked about, which is 4.7%. So my meaningful sentence would be, there was a 4.7% increase in the prices of goods and services from 2020 to 2021. And that's what this means, right? The inflation rate talks about the increase in prices of goods and services from a year to year. Now, based on the inflation results, how much would you have expected to pay for goods in 2021 if those goods were worth $1,500 in 2020? This goes to the idea of using our new value rates. So they're saying in 2020, something cost $1,500. Well, we know if you multiply by 1.047, you would get 2021. So we take that 1,500, we multiply by 1.047, and that gives us a 2021 value of $1,570.50. So to find the next year, you multiply by that inflation rate, because this 1.047 was found by taking the 2021 rate divided by 2020. So those are the 2 years that we're comparing here. Let's calculate the relative change in CPI from 2018 to 2021. Using 2018's value as the reference, does this value match the sum of the inflation rates for 2019 to 2021 in the table? Okay, so if we're going to use 2021 minus 2018 divided by 2018, right? We're using the CPI values for those years. So 270.970 minus 251.107 all over 251.107. Again, put your numerator in parentheses before you put it in your calculator. So 19.863 divided by 251.107, which gives us 0.0791, or roughly 7.91%. That's if we just calculate 2018 to 2021. Now, if we add these together, so we would have, if we move these, 1.8% here, 1.2%, and 4.7%. This is coming from those increases that we talked about on that first slide. If I add these together, I end up with 7.7%. So why are these not the same? Right? The answer is no. The sum is not the same. And the reason is all about reference values, right? When we found the 2018 to 2021, the reference for all of those, the one piece was just the 251. But for each of these items in our table, we had a different reference, right? Only for 2019 did we use the 251 for the reference. For 2020, the reference was 255,657. For 2021, the reference was 258,811. So because the reference changed every time, that gave us a different sum. And that makes a huge difference. So relative change is not additive. Number 5, Indiana's median home price went from $190,000 at the end of 2020 to $217,000 at the end of 2021. Did the median home price increase more or less than inflation from 2020 to 2021? Okay, so we know from 2020 to 2021, the increase was 4.7%. We talked about that. So how does the home prices relate? Well, if I take 217,000, because that's the 2021, and we're going to subtract the 2020 price, which is 190,000, and then we divide by 190,000. So I, again, parentheses around here, will have 27,000 divided by 190,000, and we end up with 0.142, which is a 14.2% increase. Now, the CPI, the overall inflation rate was 4.7, and the housing increase was 14.2. So, did home prices increase more or less? Well, it's more, like significantly more, right? Home prices increased 14.2%, while the inflation rate was only 4.7. I say only, but dear goodness gracious, that's a lot. Okay, and the last one here. This graph shows the annual median home sale prices for Indiana for the last several years. The Indiana Association of Realtors reports that the increase in home sale prices for 2019 compared to 2018 was 10%. However, the graph does not look like a 10% increase. Why might this be? Okay, so if we look here at 2018, I think 2018 looks to be roughly 155,000. So let's just call it 155. 2019 looks to be roughly 170,000. Okay, so the graph is giving us values, which we know we can find absolute change from values, but that's not what they're saying. They're saying a 10% increase, which talks about relative change. So let's go ahead and find the relative change. So we're going to take the value for 2019 divided by the value for 2018 divided by 2018. Okay, so 170 minus 155 divided by 155. Again, parentheses, Oh man, my pen is dead. 170 minus 155 gives me 15. 15 divided by 155 gives me 0.096, which rounds to 9.6%, which is roughly 10. So when they were talking about the 10% increase, they were talking about relative change, not absolute change. And that's why the graph doesn't necessarily look like a 10% change, but in fact, if you do the math, it is.